Git is a system, and it's used by a couple different companies. And you can also run your own. That's a source code control system. Source code control is a means by which to share information between different people and to track the changes in your code. So this is pretty important. In fact, if you look for some types of code, like if you work for somebody that has to be HIPAA compliant, as in medical code, some banking software has a legal requirement to accurately track who made changes to the source code. But Git is just downright useful, and it is so useful that it is almost universally used in software development today. And after 20-some years of using their own proprietary system, Microsoft converted the source code for all of Windows and Excel and Word and all of these applications over to being in Git. It was a huge project for them with hundreds of millions of lines of code and test code and things like that. So Git stores files, and one of the ways you can use it is a thing called GitHub. GitHub used to be an independent company. Microsoft bought them for $4.2 billion. Another one is GitLab. It's still an independent company and very profitable, so I doubt it's for sale. So let's go take a look at GitHub. And this is not me endorsing GitHub. I use both GitHub, GitLab, and I have my own Git repository. And for some stuff, it's pretty much the same in any case. So the first thing is you come to a sign in, you can create an account for free. But I am going to, that's sign up, I'm going to sign in with my account. After I click the green button to sign in with my password, I have two-factor authentication turned on using an app on my phone. So it asks for a one-time password. And that password changes every 30 seconds, so I'm not concerned about showing it to you. So this takes me into my account. Now what I'm going to do is I'm going to create a new repository. And you'll see over here is a list of some of the repositories. The University of Wyoming Education is one that I have access to. And if I click this green button, okay, you're probably not going to have as much stuff over here in the center when you first log in. But if I come over here, I get to a page that looks like create a new repository. And we're going to do demo git2. You get a little green check mark here if it's unique within your set of repositories. I actually don't want that in my account. I want that in University of Wyoming Education because we're going to do a demo for this class. And a description here. So this is just a demo. We're going to create it. We're going to build some files. We're going to walk through how this works. Now you could check boxes down here. I prefer not to. I'll show you how it works this way. If you check boxes down here, you have to do something different. I may actually do a video on that as a separate thing to show you how to do that. But I'm going to leave these boxes down here unchecked. You can always add these things later, which is the way that I prefer to do it. Now this is purely a preference, but I just click the green button and create a repository. And conveniently, if you don't check those, it gives you a piece of code to run. And this is how you set up your a blank empty repository. And you notice I highlighted that because I'm actually going to cut and paste it. And we want to start out in a directory called demo git2 so it matches up. But I am going to bring up a terminal window here, and we will do this from the command line. That is the normal way that I deal with it. There are GUI tools that you can use with Git, but I generally don't, because I use Git a lot from things that don't have GUIs at all, like servers in other parts of the world, like Texas. It has no GUI, but I can still log in and I can pull out the web pages I've just updated on my computer, load them on that computer through Git, and then I can work with them and bring them up there. And source code and applications. And this is the simple way to do it as far as I'm concerned. All right, so in our University of Wyoming, I want to create a directory demo git2. That was the name of the repository. I don't recommend putting blanks in it. It will break quite a few things. So that's generally not a good idea. And I will just paste that set of stuff that I had from earlier. And it will sit here and run. The first thing it's going to do is create a README, which I could have checked that box to create a README, but then it doesn't give me the instructions. I have to know how to do it. and I just prefer it. Give me the instructions, and at this point, I have created a connected version of this with a single file. And it is pushed back to the repository. At least that's what I'm hoping. So let's go over here and look and see. Move that window a little bit. And now if we come up here and click on Demo Git2, we see that we have a README that has that single word in it. We can edit it online. I generally don't do that, but once in a while, you just need to edit online. And you'll notice up here at the top, it says this is a private repository. We can go in and make that public so that everybody can see it. If you're doing something like sharing homework with somebody in a little group that you're working with, and I've considered doing that for the class, you want to make that public, I expect, or you want to have it private and invite them specifically, depending on what you're trying to do. Now, it says that the branch that I'm on is master. I'll show you how to create separate branches and work with those in a little bit. And it says that this was updated 31 seconds ago. Which is interesting. It isn't counting up after a second, so you know that that's just static. It's not going to count up. But if you come back to this page 3 months from now, it'll say updated 3 months ago. Now, we can go do things like we can add files. We can use the browser to navigate through files and download files. And if you look up at the top, you'll see that it's GitHub, University of Wyoming Education, and the name up here. Our class, we have one of these, and that's where I build all of the notes and information and examples for the class before you guys ever see it, probably. And if you ever want to see what I'm working on that day, you can go see exactly what time of day, when I worked on it, which pieces I built. If you're missing a file for some reason, that's the place to go, because all the work for this is done in Git before it's ever brought over to the Instructure system, the UW web system. So that's where it starts out. Now, good things about Git. I use it on multiple computers. Right now, to the left of me is one computer that I do for some of my video processing, and is the computer in front of me I do for the rest. And I have to have my notes on both. So the way that I do that is I put the notes in to Git, I commit it and push it up to GitHub. And as soon as I switch computers, the first thing I do each time is I do a git pull. And that copies the stuff on GitHub down to my local system. And I can go back and forth all day long, and I just want to get updated to what I'm doing. I do that extra git pull, I do some git commits and pushes, and I keep things in sync between two systems very happily, very easily. I also use it in a certain sense for backup. Since this stuff is saved out in the cloud someplace where they do solid backups, I'm not worried about losing code. Also, Git keeps a history of my code. Now, when I say code, I'm fairly liberal because I do things like web page development, and it includes images, sometimes spreadsheets, sometimes Word documents. The one thing I don't put in Git is I don't put in movies. There are no video files added to Git or MP3s. Those are strictly done offline using a system that will allow me to do large files, which is Amazon S3. But the rest of my stuff is generally in Git. I also keep my lab notebooks in Git and share information with my other people in the lab using Git. When I want to take a piece of software that I've tested and developed, like the visualizer, after I've updated the code for it, I commit it to Git. Then when I go onto the server in Texas where it is actually running, physically running in Texas, I do a git pull, and that updates the software on that server. So it's source code control, but it's also source code control with the ability to communicate between multiple different people very effectively. Now, that's Git. GitHub is an application on top of Git that provides a slew of other useful tools, like wikis, like code review, like defect tracking, and other things that you need over time. Now, I say defect tracking. I also use this for editing of documents where, I have a document, especially things in like stuff like LaTeX for publication, and there are mistakes in it and somebody's editing it, those mistakes get tracked as issues in Git. And I come back to them, I can then turn around and they can edit one day and I can see what they noted and what they put down as errors or things that need to be fixed, pull those back out and work on them. And it gives me a workflow between multiple people. And the magic of Git is the fact that it does facilitate a multi-person, distributed over the web workflow. Now, there are lots of features we're not going to talk about. I have the Git book, which is almost 700 pages and about as entertaining as reading, a federal law. I admit it, although I do dig things out of the book once in a while. But it just is not the most entertaining reading. The plot is really thin. But it's useful. And like a lot of things, sometimes you've got to learn the useful and not worry about this is deadly dull. So that's basically how you set up a Git repository. Let me show you how, at the very simplest level, you change stuff. So let's say that I want to change the README. So I'm going to go into an editor. You could do this in Visual Code. You could do this with Notepad++. But this is a text file in this case. So I'm going to use the editor I normally use. And let's say that I want to change the README to say that this is a demo for class of Git. Now, when I get done with this, I have one file, and I can do git status, and that'll tell me which files, not git status, G-I-T, git status, which files are changed. Let's say that I add another file here. I do just this, just has a blank line in it. Now if I do git status, it says I've got one file I've changed, modified, and another file that is not been added to the repository. So I can say that I want to add these, add the changes. Okay. Now these are staged. They're not actually added. They're just like a copy of them has been taken and hidden away inside Git stuff to say, okay, you're planning on making this change. Now I can go back if I do git status now, and you'll see it lists those as these are the files we're going to work with. Now if I go back to README, let's go to other file. And let's say that this is other file. Doesn't really tell you much, but now if I do git status, it'll say, oh, you were planning on doing this other copy of it, but you've changed it and now it's modified. If I want to take the current version after I've modified it, I do git add again. And now both of these are staged to be changed. Now, if I want to take those changes and make them a part of my repository, I have to commit them. And I do git commit. You can put a message in. You can use an editor if you have it set up. But the easiest way is to do it on the command line and say what it is you're changing. And quite often, if you are changing source code for a program, you're going to want to set it up so you have an editor. You'll give it a title. You'll write an entire paragraph explaining what the change is. You can do that from the command line, but it's not very convenient. But just for this demo, we're just going to add this, doing a demo for Git because I don't have much to say about this. Now, if I do git status, you'll see that it says that everything has been committed, but it hasn't been pushed. Your local copy has been changed, but the master copy that is at GitHub hasn't been changed. So it's just locally you've changed it. And you can back out this change. You can do weird stuff with Git, like time travel or cherry picking changes that you want. That's the point in time when you need the Git book. But for most uses, this is probably enough for a wide variety of uses. So I do git push, and it takes the changes that I've committed locally and sends those up to the master copy at GitHub. Now, things that happen along the way. You do git push and it gives you an error that you're not authenticated. Though that's not the first error it's going to give you. The first error it's going to give you is it's going to say that you've got to set some global values to tell it who you are. And it actually prints out what this is. And it's git config -g username and whatever username you're using at GitHub and email, because it needs to know who your email and who your user is. So you take care of those. The next most likely thing is that it's going to complain about is you do a git push and it says you're not authenticated. Authentication is a big deal with Git. And I use a system called SSH. The default is not SSH. The default is to use HTTP authentication. And I believe it will be set up correctly for you to do that as soon as you've used your username, and it will prompt you for a password. That would be what I would expect. However, if you go to do this and you end up stuck at this point and it's not authenticating, then you're going to have to create SSH keys like I did. And those SSH keys are strong authentication. It's like passwords that can't be broken unless you lose your side of the key. Now, the caveat here is once you do the SSH route, you have strong authentication. If you lose your side of the key, the private key, it's gone. There is no, I'll type in an email and get a recovery thing. So you really, really want to make certain you back up your keys. You do not want to lose your keys. And let's put that more clearly. You do not want to ever lose your keys. Like never, never, never. So that's pretty important. Now, what do I do to prevent the possibility of losing keys? Well, I use a YubiKey as part of my login to GitHub or GitLab or my own Git repository. And since the YubiKey is actually set up as strong authentication, I can use it to recover from other things. And that takes me back to, two-factor authentication and how that's set up. I mean, for class work, it probably is not critical. But you go out in the real world and you have to authenticate, you're going to have to do these things to make certain that you are the person that's making changes to the code. So that's kind of the basics. I'm going to talk about branching after I do some diagrams on what branching is, and we'll talk about how you do branches. I use branches all the time for making changes, but I want to show you diagrammatically as a drawing how that works before we run through a demo with this.